Jurgen selected. How's it going? Good morning. You just got done taking the test on functions. Well done. We are moving on. We are actually going to move in a different direction, though, than my trig and pre-calc class. So far, we've kind of been doing the same things as this class is to prepare you for trig and pre-calc, but we don't want to do all the exact same things. That's going to be boring for you if you take that class. And a lot of the skills I've been teaching you guys lend themselves well to something different. So while that class is going to zig and go in one direction, our class is going to zag and go in this direction. So stop me if you've heard this one. A train leaves New York traveling 60 miles an hour at noon. At 2 o'clock, though, a train leaves Chicago traveling 70 miles an hour. Where will those two trains meet? That's kind of an old cliche math problem, but to solve it, you would need to write a system of equations. So without further ado, let's take some notes. Let's look at some of this stuff. What is a system of equations and what does it look like to solve it? And then finally, I'm going to give you a way, something called substitution. So let me switch this camera over and go to my notes. The notes look like this. It says Unit M. I called it M because it's my choice. And we're going to learn something called a matrix, matrices. So Unit M, systems of equations. A train leaves New York. Yeah, we talked about that. To solve that type of problem, we would need to make an equation for the New York train. Okay, so I just made this equation. I said x plus y equals 2. And then we would need to make an equation for the Chicago train. Based on that information, we can kind of figure out when will those be at the same place at the same time. And that's a system of equations. So a system in general is more than one. A system of equations, yeah, we have one, we have two equations. We could have three, we could have four and craziness. First thing I want to do is kind of look at this graphically. So I'm going to take us over to Desmos real quick. And here we are. I have right now one of the equations down for my New York train. And I just made this equation up. It's not really the New York train. But the equation was x plus y equals 2. So every dot you see, every point on this line, the x coordinate and the y coordinate have to add up and give me 2. So I can click anywhere right there. You add those two. You add those two. I put some easy ones so you could see it. Click off somewhere. There it is. Negative 7, 9. Add to 2. 1 and 1. Add to 2. 3 negative 1, add to 2. So these are all the points that would add together and get me 2. The other train is going to be this one, the one in red. If you subtract any of the 2 points on this red line, one minus the other, you will always get 10. Yeah, so 10 and 0, that makes sense. 11 and 1, that makes sense. Any of these points, if you subtract them, you will get 10. So we want to know, when is the New York train, when is the Chicago train at the same place at the same time? I'm just asking when these two lines cross. So we look for this point of intersection, and we get 6 comma negative 4. Sure, 6 comma negative 4 are two numbers we could plug in here that make this equation true, and they make this equation true. That's what it means algebraically, right? Graphically, it's where the two lines cross, piece of cake. Algebraically, though, that point is an x and a y that makes this one absolutely true, and at the same time makes this one absolutely true. There's only one set of points that does that, one x and one y that work for both equations. It's this one right here, 6 and negative 4. And we just solved a system of equations. So let's go back to the notes and kind of show you how to do this. Why does it look all crooked? I didn't even mess with it. Okay, so we have our system of equations. I did the graph right here. We call this the solution. So the solution looks like this. It's an x comma y. I'm going to be a stickler with this. Some things I'm picky about, some things I'm not, some things I'm not, but I need it written as a point, x comma y. When you solve these, I want the x coordinate comma the y coordinate with these as an ordered pair with parentheses. This is what we are doing, solving a system of equations. Awesome. So now let's move on. Now, how do I do that if I don't have a Desmos right in front of me? What if I have to do this using like math in my brain and pencil and paper? So I'm going to show you some different ways. This whole unit is going to be about different ways to take care of this. The first one is called substitution. And this is one of those ideas I was talking about that kind of makes sense because we've been doing something just like this when we were dealing with functions. So it's a pretty easy crossover for us. So we are going to solve this system of equations. This is my New York train. This is my Chicago train. I want to figure out when they're in the same place at the same time. I want to figure out what X and Y are that would work for both of these, right? Because there's a bunch of numbers I could plug in here for X and plug in here for Y that would be true. But there's only one set of X and Y that makes both of them true at the same time. And that's what I need to find. So step one to making this happen is getting a variable by itself. Like I need like x by itself on one side of the equal sign or y by itself on one side of the equal sign. And thank you, Mr. Edwards. I already gave you that. Part of this problem, it says y is 3x minus 11. So Cool, done. Step two is the substitution part. We are going to take that entire equation that we just solved, y is 3x minus 11. We're going to take this entire expression for y, and we're going to substitute it wherever I see a y in the other equation. You got to use both equations. So I'm going to come up here, I'm going to take this y out, and I'm going to put parentheses in its place. In those parentheses goes what y is, and I know what y is. Y is 3x minus 11. And this kind of sounds like a composition of functions to me. We're substituting one whole thing into another. That's kind of why I chose this. So we're here. Now it's an algebra 1, algebra 2-ish type of problem. I need to solve for x. So I'm going to distribute negative 3 times 3x, negative 3 times negative 11. And I'm going to get x minus 9x plus 33, negative times a negative, equals 17. And we solve from here. X minus 9x is negative 8x. I'm going to subtract 33 from both sides. I'm going to divide by negative 8. 2. Awesome. So this would be the point of the problem where you're so proud of yourself that you think you're done. I got an answer. X equals 2. And x does, in fact, equal 2. But remember, the solution has to solve an x and a y that makes both of these true. And so far, all I have is an x. Okay, so we have one more little orange star here to do. The last step of this, once you know what x is something called back substitution. It's exactly what it sounds like. I need to go back and substitute this new information I found into one of the equations and find the other piece of information. So here was our original equation, y equals 3x minus 11, but we just figured out x is 2, so I'm going to plug a 2 in there. And I'm going to get what y is. Y is negative 5. Final answer is the point where those two lines cross. This is the x and the y that would make both of those equations true. This is how you have to write the solution. Not too bad? Kind of, sort of. Okay, let's do one more together, and then I'll cut you some loose with some of them on your own. Example 2. Take a minute, hit pause, try it out on your own, then come back to me. Cool, you're back. I don't know. I hope so. So hopefully you hit pause and tried it. Step 1 was to get one of the variables by itself. Well, that's really easy. We have both of them by themselves. Y is equal to this one and y is equal to that one. So what we do is we take the y out of one of them and we substitute that whole expression into the other. But if I know y is this thing and y is this thing, then these two things have to be equal. That's what we're doing. I'm just taking this whole expression and substituting it in for y down here in this expression. So these two things have to be equal to each other. Okay, this kind of looks like something we just tested on. Let's clear some fractions. I'm going to multiply everything by 2, right? Common denominator. And it looks like this. No more fractions. Love it. Every single thing. Both sides of the equation by 2. Now I'll add the x to the other side, right? Add x to the other side, 7x. I'll add 14, because I'm minus 14. I'll add 14 to the other side. And I'll get negative 14 equals 7x. I'll divide by 7 to get x by itself. And x is negative 2. Awesome. We're not done. So now we take that information that we just got, x is negative 2, and we back substitute. We go back into the problem and substitute it. Here, you can pick any one you want. It doesn't matter which equation you pick. Some are easier than others. In this case, I think the bottom one would be easier. I'm going to substitute what I just found x is right in there. We're going to do a 3 times a negative 2, negative 6 minus 7, negative 13. Final answer are my x comma y. That's the point on the graph where these two things would cross. Nice. In less than 10 minutes, we're learning about solving systems of equations using substitution. So you got some things to do. Thing number 1 here, your stamp for tomorrow is to try and do these 3 questions I'm about to show you, and then bring your answers to me and we'll talk about them. Step 2 is I have a worksheet practicing that I'm going to give you for a grade. So I would try these first, do the best you can with them, go to the worksheet, and as always, if you miss them, you may fix them. So here are the 3 questions. This is all on the Watt as well. It's hard to make them fit, or you can write them down or take a picture, whatever you want to do. But 1, 2, and there's finally number 3. We are solving systems of equations. Some vocab here, right? Using substitution. Algebraically, it's the x and the y that makes both of these things true. Graphically, it's where 2 lines cross. Be able to summarize that. I'm sure I'm going to ask you to do that. It's a typical Mr. Edwards type of thing. Anyways, we are moving on.